interesting. It'd be nice if I could talk. I really not very yeah. If you're not, the tongue's not working tonight. What's going on, everybody? Thank you for clicking on the clip. I'd like to brain fart. Coffee? Coffee. This is a coffee mug. And yeah, it's 9:30 at night. Anyways, welcome back to the channel, everybody. Thank you for clicking on the clip. Don't forget, hit that subscribe button if you haven't subscribed. Hit that like button. It only takes a second, and it really helps out the channel. Comment if you really want to comment. You got something to say, ideas, tricks, tips, or any kind of interesting. It'd be nice if I could talk. I really not very yeah. If you're not, the tongue's not working tonight. Anyways, welcome back to the channel. Thank you for clicking on the clip. Don't forget, if you haven't subscribed, if you're not subscribed to the channel, hit that subscribe button. It really helps out. Helps push the videos out to more people and gets the channel known. Hit the like button. It does the same thing. It all kicks that algorithm in the booty and gets it rolling on down the road. We're going to be talking about the give and take of horsepower and motor building today. I've had a couple of comments saying that, well, if you do this, it does that, and if you do that, it does this, and it doesn't really seem like... I know these guys build motors, and I know they're reputable builders, but at the same time, it really makes me wonder how much they've really learned over the years as to the give and take of horsepower. Because I got into an argument with somebody, not really an argument, but he kind of went against the turbo crank video. I said something about turbo cranks. He said something about snake oil. I told him, show me the dyno results. This is an example. He turned around and stated the fact of, you are removing material, therefore you are increasing the volume of the crankcase in a two-stroke, which is a very good point. You are doing this. The amount of volume that you're increasing is minimal. You'll probably create more volume with a 1/4 inch reed spacer than you would in any turbo cut crank. The reed spacer will take the power curve and bump it. 1/4 inch, 500 horsepower. You go 1/2 inch, 1,000 horsepower power curve bump, meaning that wherever the horsepower bell curve is, if it starts going up in peaks, the main peak is going to be lifted 500 to 1,000 RPM, depending upon how far away you move the carburetor from the actual motor. Intake rotor makes a difference in length. Exhaust, not so much. So, because the intake runner on a two-stroke is included in the crankcase volume, you need to keep that in mind. What we've got here are some videos showing some give and take. I will go through and explain things as the video goes through. They're simple animations. I'm still learning Animate, not putting a lot of time into the animations. These are quick sketches, and they get the point across. I don't need to go into real in-depth animations like anime or cartoons or Scooby-Doo or any of that stuff to get the point across. This is simple stuff, basic motor building techniques. You have to take if you're going to give. You have to give if you're going to take. Yes, a stock motor will outlast a performance motor under similar maintenance routines, just because the extra horsepower puts extra strain on bearings and other components. So, with that said, we're going to go into the video, and we will start out with a 4-stroke head, and we will go into how the porting is, what happens when you move the porting, what happens with the cams. When you raise them, you change the duration, you change the lift. All of this stuff plays a role in horsepower. A balanced and blueprinted motor is a motor that has been matched. The intake matches the cams, the flow, the cams all match the flow of the head, and everything in the motor has been balanced. If you're running multiple cylinders, that means you go through and you make all the rods match weight, you make all the pistons match weight with the rings on them. You have to take into consideration piston, pin, and all that stuff. So basically, you're taking a complete rod assembly with the piston and everything on it. You're putting it on a scale. You're getting a gram weight. Turning around, if you got multiple cylinders, you go with the lightest one, and you bring all of the other pistons down to that weight. That is a matched, balanced motor. Also, with a 2-stroke, you weigh the pistons. You make the pistons match. You weigh the rods. If 2-stroke cranks, you have to press them apart. So if you're building a motor and you've got to redo the rod bearings anyways, this is the perfect time to turn around and balance and blueprint a 2-stroke like a Banshee motor. Twin cylinder, watercraft motors, snowmobile motors. 3 cylinders, 2 cylinders, multiple cylinder 2-strokes. You can match these things up and you can get them balanced. A single cylinder 2-stroke is a totally different balancing factor. I am not going to get into that in this video. That has to do with compression, horsepower, how hard the spark hits. A lot of factors come into play when it comes to balancing a single cylinder 2-stroke motor. So we're not going to get into that in this video. This video is basic flow, give and take of horsepower. How you get the horsepower, where you remove things, where you put things, how you adjust things, and what happens when you modify certain components to get more power. You can replace cams. You can have cams custom cut. There's millions of different options out there. Today, it's basic give and take of a motor to get some good horsepower out of a motor and see how things work. So, here we go. Alright, so what we have here is a 4-stroke cam. It's got the valves, intake, exhaust ports. Now, when you go in and you modify these ports, you can completely destroy how the flow goes, or you can help it go. By adding to these and making them bigger, you increase the amount of volume and airflow that can go through. The valves only open so far. When you have modified cams, some people are saying stage 1, stage 2, stage 3. Other people actually use cam numbers. But either way, when you're looking at the cams, the higher the lift, the higher the duration, the more the valve stays open and the more the valve opens. There is a point where excessive lift will not help. Basically what you're doing is you're just increasing the duration of the valve being open by opening it further. This is not always good because then you can run into piston intersection issues where the valve opens too far on overlap or something and you smack the piston and you're replacing the valves. So you want to have the cam set so that the valves avoid the piston, but they open up to the most that equals the flow of the intake in the exhaust, so that as they open up, it pulls the air through in an even and uniform fashion and closes quickly. Exhaust is the same way. You want the exhaust to open quickly so it helps the gases go out, and you want it to also kind of close quickly so that it seals back up so that you can build compression and everything back up. So by making these bigger, you're allowing more fuel. You change the cam size, you make them bigger, you're allowing even more fuel and air in there, which actually bumps up the compression and increases horsepower. There is a point where once you're over 180 psi in the cylinder, you do want to kind of go with a race gas, like 110 octane or at least 100 octane. but that's a different video altogether also. So with a four-stroke, this is your basic horsepower creator. Two strokes are not the same. We're going to be going over the two strokes here in a second. This is just a four-stroke. You want to also, something that you run into is where the valve guides come down through is a casting mark. You don't want to port too much of that casting mark away because that is actually reinforcing the valve guide holding everything in place. These all need to stay in place or else bad things happen quickly. Motors go boom. Now, on with two strokes. With two strokes, what we have is you've got the cylinder, and these are the transfer ports. Transfer ports are what allow the gas to go from the bottom end to above the piston. These transfer ports come in, and they're angled. There's two different angles here, being I wanted to show how different things work in a transfer port. This angle here on the back side, when the air comes up and through, it will flow smoothly. If you have a more gradual, it'll actually flow faster, and it'll still flow smoothly. This little kink right here will cause a roll on the backside, and it will impede the flow of the air getting up to the top, which will actually hurt the motor builder. What we have here, this is the intake port, this is the exhaust port. Intake port's got reeds, here's the reed spacer. This is what causes a 500 RPM lift in the power curve. For power in the low end to mid range, you don't want to use a reed spacer. You want these reeds up as close as you can possibly get, and this will help increase your bottom end power. If you move it back, it will help increase your top end power. Increasing the size of these ports increases flow, increases the amount of fuel and air that you can get in, and the amount of fuel and air that you can get out. Remember, you can always eat more than you excrete. So you're taking in a lot more air, fuel and air than you're letting out. Just like if you go to a buffet. What we have here is, I'm in the way. What we have here is, all right, this is the intake port. These are the transfer ports. Most transfer ports, if it's a bigger cylinder motor, 125, 250, 500 cc motors, have a split bridge in the transfer port. From factory, the bridge looks kind of like this with a little bit of a flat top on it. When people go in and they do a lot of port work, they will do what's called a knife edge port on the bridge. This little piece right here that goes across. This actually, from dyno results and stuff that I was shown in school, is not a good way to port. You want more of a teardrop effect, and it'll actually let the air hug the divider. This knife edge causes a lump right here, and it causes a roll. If you have more of a teardrop shape splitter in between, if you have more of a teardrop shaped bridge in your transfer ports, it'll help the flow, and it'll actually increase the flow, kind of like the wing of an airplane. That's everything that you're trying to do is increase flow. Everything is increase the most amount of flow of air and fuel that you can get into it. You're trying to stuff this thing as full as possible and still keep it running. Now, these are the side views of the transfer ports. What we have here is, I did a standard, say this is a standard size transfer port. When you go to modify these, you can go wider, creates more volume to flow. If you go higher, that means the transfer ports open up sooner, allowing fuel to come in earlier. If you go lower, they stay open longer, but you end up with scavenging out the exhaust ports. So some of your mixture, some of your fuel and air leaves and does not get to the top end above the piston. So if you go too low, you're actually robbing yourself of performance because you've got too much of an escape factor for the air and fuel to get out before it gets fired. Crankcase volume. We were talking about the turbo cranks earlier in another video. Turbo cranks you cut into the crank itself. Remove material. It creates not excessive volume, but a little bit of extra volume. You've already gone in, you've opened up the transfer ports. You've already gone in, you've modified the bridge. You've gone in and you've opened up the intake and the exhaust. Why? Why would you leave the crankcase volume the same? You're creating extra pressure because you're trying to stuff extra fuel and air in there. And that's a possibility of blowing out seals because you're trying to force too much in there. It will only pull in as much as it possibly can. Add extra volume, you can get extra fuel and air in there. So, you do not build a turbo crank by itself. The turbo crank is a horsepower increasing device that helps get more fuel and air up above the piston through the transfer ports to be fired. The more fuel and air, the more compression you have, the more horsepower you get. It's that simple. Things that you do not want in your port work. You do not want sharp edges. You do not want casting marks. You do not want lumpy, uneven surfaces. You want smooth flow, smooth radiuses, get rid of sharp edges, round over the sharp edges, give them a teardrop shape, improve the flow as much as you possibly can in all of the areas that you can. We're going after efficiency and we're going after performance. I've got a guy who does all of my motor boring because I don't have a boring bar. He is a third generation drag race motor builder. He builds 860 cubic inch aluminum block motors all day long, every day, and laughs whenever I bring in a 250cc two-stroke for him to try and figure out. I asked him one day why after I'm done porting, why I have to drop a jet size. He said it's because I increased the efficiency of the flow of the motor. This is usually only done on my bottom end and mid-range port motors. My race motors, my race port work, I hog waller those things and they flow a lot. So those need bigger jets because they need a lot more fuel to accept the amount of air that I'm flowing into these things. Alright, I don't know if I've confused you guys, if I've helped educate you a little bit more. If there's any questions or comments, throw them down in the comments section of the video. I will go in and detail and try and explain any questions that you guys have. I know some of this stuff is kind of hard to understand. Some of it doesn't make sense. Kind of like electrical, it doesn't have to make sense to work. Sometimes rational things aren't the answer. If you make it bigger, you got to make it all bigger. If you want to build a motor so that it's got horsepower, you've got to build the whole motor. You don't just do a little bit here, you don't just do a little bit there. If you want horsepower, you make the motor match. Exhaust on a two-stroke, exhaust on a four-stroke, it all makes a difference. How the cones are laid out in a two-stroke, how the exhaust is made, it will change the power curve throughout the entire thing, depending upon who built the pipe and how the pipe was built. With a four-stroke, if you've got smaller exhaust, it creates more back pressure, it gives you more bottom end. You open the exhaust up, it relieves the back pressure, it gives you more top end. It's a give and take. You remove here, you add there, it changes power curves here and there. If you're looking for a good balance, you've got to sit down and figure out what you're trying to do. Everything is application specific. If you want a good, reliable motor, go in there and get rid of some of the casting marks. You do not mirror polish the intake. You need scuff marks. Scuff marks on the intake, scuff marks on the transfer ports. You can mirror polish the exhaust if you really want to. Polished exhaust is fine. It gets dirty over time. It doesn't stay nice. Jesus. Indigestion. Yeah, eat more. Let's see what else. I'm sure I'm missing things. I really am. I just wanted to get this video out there. Like I said, if there's any questions or comments, put them in the comment section. I'll try and hit them as best as I can. This is one of those videos that is more of a quick explanation and get your attention and show you that you can't just build one part of the motor. You've got to build the whole motor for everything to work in conjunction with each other. If it's not a smooth flowing motor, it's not going to work great. If things aren't balanced, you're going to have issues. There's always, always, always something that can be improved to a point. There is maximums to these motors. There's maximum piston velocity. There's maximum airflow. There's a lot of maximums. So you can max out a motor if you know what you're doing. Or you can screw a motor up if you don't know what you're doing. So, with that being said, y'all have a great night. I appreciate you watching through all the way through to the end. And we'll see you in the next video. I'm doing a fish tank reseal. I had a 55-gallon pop, so the bottom started leaking. So I've got a 55-gallon that I'm resealing and doing a video for that. So that's going to be coming up here shortly too. I appreciate the support. I appreciate the watches. And y'all have a great night.